Hi all, welcome to another interesting code snippet challenge. Right now you're viewing the code snippet that I've shared on my Telegram channel. This code snippet seems to be straightforward, but in order to crack this code snippet, we need to understand few areas of concepts. Like for example, we need to understand the interface new style of method called default method that got introduced in Java 8. Then we need to understand the typecasting, object typecasting. So there are areas where we need to have knowledge in order to crack this code. So let's get straight into the IDE and see how we can understand the concepts that's been integrated in this code snippet in order to crack it. So right now I'm launching my IDE. Let's go ahead and create a new class named tree. And this class is going to carry a main method. So before we step into writing the code of the code snippet, let's understand the concepts of interfaces. That is very important. So in order to understand the concept of interface, first we need to understand the traditional way of how the interface used to be. So traditionally, we used to have the interface carrying only abstract methods, You can have n number of abstract methods inside an interface. So what is an abstract method? Abstract methods are the methods which does not carry a body in it, means which does not carry a definition. There is no definition for abstract methods, no definition, right? So traditionally, meaning is prior to Java 8 version, okay, that is until Java 7, okay, it's an old style of interface. But from Java 8 onwards, we are going to call it as a new style of interface, right? So what is there in the new style of interface? That's what which we need to understand, right? In old style, we call it as a purely abstract. Interfaces are purely abstract in nature, meaning is it will only carry abstract methods. That means 100% abstract methods alone will be there present inside an interface. But in new style of interface, that's not the rule. In new style of interfaces, starting from Java 8 version, new style of interface, starting from Java 8 version onwards, an interface can carry abstract method, n number of abstract methods, or single abstract method. We do have another definition for single abstract method called as functional interface. That is SAM interfaces, SAM methods we call it as single abstract method. But that's out of scope of this discussion for this particular code snippet. So new style of interface starting from Java 8 onwards, you can have abstract methods, and number 2, you can have default methods. Default method. So what is the meaning of default method? A method which can carry a definition. So abstract methods, no definition. So who will give the definition for the abstract method? The class which is implementing the interface, that class have to provide the definition. But default method will have a definitions in it. So this is something new compared to the old style of interfaces that we used to have it in prior to Java 8 version. Then third feature in the interface from Java 8 is it will also accept static methods. But according to this code snippet, the code snippet doesn't carry a static method. Okay, so static method meaning is it's a method which is marked as static, and this method will also carry a definition. So the only method inside an interface which does not carry an definition is your abstract methods that we are aware of, right? And interfaces usually used to have only abstract methods, 100% abstract methods. But from Java 8 onwards, it carries an abstract method, it carries a default method, it carries a static method. Static methods and default methods will carry a definitions in it, means there will be a body for the method. But in abstract methods, there's no definition, meaning is there's no body for it. So this piece of information which we need to have in order to crack the code snippet that I've shared. So having this piece of information, we need to understand how the code snippet have been drafted. Okay, so first thing is, according to the code snippet, we have an interface called plant. Interface plant, and this interface is carrying only an default method. As I said, you can carry an abstract method inside an interface, and you can carry a default method inside an interface starting from Java 8 onwards. Okay, that is a noticeable point. Starting from Java 8, you will be able to have default methods with definition, right? And also we can have static method. Static method is again going to carry a definition in it, but abstract methods are not defined. Okay, no definitions will be there. Okay, so keeping this piece of information, so according to the code snippet, there is only a default method, default string grow. Okay, and you will have a body in it which return a value called grow, right? So we have a string value which is written from this method. Now the thing that you need to notice here is we have a grow method written, and this grow the grow method is defined, and the grow method is returning a string, but this method is default method, so there is no compile time error. As you notice, why there is no compile time error? Because from Java 8 onwards, interface can accept the definition for a default method. So default method can carry a definitions in it, right? So that's the main observation that we need to have from the code snippet. So the code snippet carries an interface called plant, and which has a default method called grow, and the grow method is already defined, and it is returning a value called grow. Okay, so why there is no compile time error, that we need to understand, right? So I'm going to the project, go to the properties of the project, and from the properties you have to notice the compiler. So Java compiler. So right now the Java compiler is mapped to Java SE 17. Okay, well ahead of 8. So this feature got introduced from Java 8, but right now I'm having Java 17 in my mission. So meaning is, starting from 8, any version, it could be a 9 or 10 or 11 or 14 or 17, or even right now we have 18, Java 18. Any of these versions will support interfaces carrying default method and static method along with abstract methods. Okay, but prior to Java 8, that is until 7, it will carry only abstract method. 100% abstract methods are alone permissible inside an interface. So since my compiler for this IDE is mapped to Java 17, so obviously it's pretty clear that it can support default methods inside an interface. Okay, so next I have another interface here where you need to be very careful in order to crack this code. So I have an interface called living. So we have an interface called plant, and we have an interface called living. So inside that living, I have same method that we have defined in plant, but the only difference is it will carry an access specifier called public. So public default string grow. Okay, and this method, if I terminate it, it becomes an abstract method. But if it's an abstract method, you cannot entitle the method with default keyword. Okay, you cannot use default keyword if it's going to be an abstract method. So default keyword is used in order to declare the method as a default, so that you should have a body for the method. You need to define the method. So this is what is an abstract method, right? Whether you use a keyword called abstract or not, it's by default treated as abstract inside an interface, right? But what we have in the code snippet is the method is a default method, and the method name is grow, and we have a body for it. And here in this method, we are returning a value called growing. Okay, so growing is the value that we have from the return statements. From the return statement, we have a value called growing from this grow method. The thing that you have to notice here is there are two interfaces. Okay, so one, you have the interface called plant, and you have an interface called living. Both the interface carries a method called grow. Signatures are same. Okay, 0 parameter, here also 0 parameter, right? Return type is string, return type is string, and here also return type is string. And this is a default method, this is again a default method, there is a body in it, and here also there is a body in it. The only thing that differs is the value that you are returning is different. Here it is grow, here it is growing. And one more thing is here it is public. Here we haven't defined any access specifier. Whether you give an access specifier here in the default method or not, it is going to be by default treated as public. Usually we used to say default as a default access specifier for the methods, but that's not the case for interfaces. This is applicable even for abstract methods. Abstract methods have to be public. So by default, the methods inside an interfaces are public methods. Whether you explicitly provide a public access specifier or access modifier or not, it's going to be treated as public. So this is only a distractor, nothing much in consideration. So public, explicitly provided, here implicitly it's public. Okay, implicitly it's going to be treated as public. So that doesn't make any big difference according to the code snippet, it's just a distractor, but it's good to understand that all methods in an interfaces are by default public in nature. Okay, so the main problem that we have here is both the interfaces are carrying the same signature of the method. That's where the tricky part here is. Anyways, let's go ahead and see what's going to happen if I'm going to implement both the interface. So when I say implements, the first one is a plant. So when I say implement, there is no problem. Usually what we used to see or experience when we implement an interface is the methods inside an interface need to be overridden. If it's not overridden, it will raise an error. The compiler error will be there. But ultimately, we are not getting any compiler error after implementing an interface. This is something pretty new to watch. Usually, we used to have the error noticing that this class doesn't implement the methods coming from the plant. But technically, we don't have any abstract methods here. 0 abstract methods, right? 0 abstract method. So only we have a default method which is already defined. So this method is getting inherited into this tree class. That's the only thing that's happening here. Okay, so we need not override them explicitly because already the body is there in it. If needed, you can override it. Otherwise, you can make use of the same functionality which gets inherited into the tree class. So when I say implements plant, there is not of much problem here from the compiler perspective. But when I say plant, comma, okay, living, here where the challenge is. So when I implement two interfaces, okay, plant and living, okay, plant is implemented and living is also implemented. Now, technically speaking, when we have a default method with a body, it gets inherited. But now the compiler is having a challenge here. You can notice there is a compiler who is facing a challenge here. What the compiler says is, hey, listen, you're going and implementing plant and you're implementing living. When you're implementing these two interfaces, both the interfaces are carrying the same method signature. So I'm pretty confused. Which method should I inherit into the tree class? That's an obvious a confusion that occurs to the compiler. And this is the kind of a problem that we used to face in C++ because C++ supports multiple inheritance, right? Multiple inheritance. But what we say from Java perspective is Java does not support multiple inheritance. Java does not support multiple inheritance. That's from the perspective of class. But in terms of interfaces, interfaces are on top of implementations. So you can have n number of interfaces to get implemented. Yes, of course, because interfaces will carry only abstract method. Even if you have the same method signature in the abstract method, if you override, you need to override. When you override, it overrides as a single method applicable for both the interfaces. So at the time, we never have any challenge of like how we are having it for the default methods, because abstract methods need to be overridden explicitly. But here I'm not overriding. When I'm not overriding, when I'm leaving it as such, then the confusion occurs. The grow method of both the interfaces are leading to a trouble. So this is a main issue. That's the reason Java avoided multiple inheritance. But unfortunately, Java have to introduce this default methods and interface, because for backward compatibilities, Java 8 have introduced a feature called lambdas, okay, which is a functional interfaces. So there, when they brought in the lambdas, the existing Java API got impacted in many ways. So in order to avoid the impact, they started to plug in the default methods in order to give a better backward compatibility support. Anyways, that's out of the scope of discussions. But right now, what we have here is an error. So let's observe what the error is all about. So when I hover the cursor, it says duplicate default method. Duplicate default method named grow is available here, and I am personally confused. I am meaning is the compiler is personally confused. Which method do I need to inherit? So this need to be resolved explicitly by the programmer. Otherwise, the error keeps popping up. Okay, duplicate default method named grow with the parameters as also same. If at least the parameters are different, then obviously both the methods gets inherited. So let's say I have an int a here. So one is carrying an int a, another one is without a parameter. Now you can see the error got disappeared. Why the error got disappeared? Because both the methods are inherited into the tree class. Both the default methods are inherited into the tree class. Since their method signatures are different in terms of their number of parameters, they are different. Either the method name should be different or the method signature of the parameter should be different. It doesn't matter whether you're going to return a string or an integer. It doesn't make any difference. When it comes to the multiple inheritance of the default methods, we need to have that checked. But unfortunately, we cannot say that all interfaces will have the method names with different, or the signatures of the parameters will be different, because we might be getting the interface from an external API. So I might be using 2 or 3 external APIs, and unfortunately, 2 of the third-party APIs are having the method default method name in their interfaces as same, and the signatures are also same. There are possibilities of such similar methods might occur in 2 different interfaces coming from the external API. So at that time, when I'm trying to implement both the interfaces in my application, then obviously I will end up with this problem of a duplicate method, right? So in order to overcome this issue, what they say is the first solution is going to be we need to override them explicitly. The grow method need to be overridden. So that's what we have as per the code snippet. So in the code snippet, what we have is we are having the similar method signature public string grow, and it's going to carry, okay, as in this case, it's going to carry an int height, and we have an definitions for it. It's a class, typically tree class, and this is returning super growing. Super growing. Okay, so when we have this return of the string, which is more similar to the living interface and the plant interface. Okay, so we have this super growing. Sorry, that is a challenge in the double quotes. So right now we are returning this super growing. So here we are returning grow, wherein here we are returning growing, and here we are returning super growing. But technically speaking, still the error exists. You can notice that still the error exists even after it looks like overriding, because same method signature string grow. The main point here is we have a parameter. Oops, that's a problem, because these two methods, starting from your plant interface and the living interface, both are carrying the method without a parameter. So when you have a method like this method is closely relevant to tree class alone. This is technically not coming from neither the plant nor the living, right? Because their signatures are different. They have zero parameterized signature. But here you have int height. This is a tricky part as per the code snippet. So we cannot call this as an overriding method. So I cannot demarcate it with override the annotations, right? So I cannot use this. Why? Because technically this is not an overridden method, because it carries an int parameter, but living and plant doesn't have the parameter, right? So it's pretty clear it is ending up with a compile time error. Okay, it is ending up with a compile time error. So how do we resolve this issue? In order to resolve this issue, I'm going to remove the parameter. If I'm removing the parameter, then the errors are resolved. So we have overwritten explicitly. We are overriding the method explicitly from the plant and the living. But unfortunately, we are returning the values here, right? So these written values, the grow and growing is not going to be the same, because here we are saying super growing, right? So when we are saying super growing, then technically what happens is we have overridden altogether both the methods and we have given our own definition here, right? So that's what is technically happening here. So if in case you want to reuse the functionality of this living and the plant after overriding, in spite of overriding, you still need the business logic of the grow and the grow method of the plant and the grow method of the living interface, then we have to do another approach. So return, so let's say I want to concatenate all the results. Okay, so in order to call the base interface default method, we are going to use the plant, the interface name dot super. Super keyword is used to refer to the super interface or super class, right, or super constructor. So plant dot super dot grow. Okay, so this will return the grow value, the return value of the plant grow method, plus I want the return of the living interface grow method as well. So there we need to say living dot super dot grow. So this is more similar like scope resolution operator that we use in C++, right? Because in order to avoid the multiple inheritance challenge, they will be using a scope resolution operator. But here we are using a super keyword in order to resolve this multiple inheritance with default methods issue. So, but we need to prefix it with the name of the interface. You cannot just use super.grow because we have two supers here. Which super are you pointing? That you need to refer here. Plant.super.grow, living.super.grow. So now what happens? It will carry all these three values: grow, growing, and super growing. Okay, but this is not what we have in our code snippet. So code snippet only carries return super growing, right? So let's say super growing. So now after having this written and moreover it's not an overridden method as per the code snippet. So we have a parameter. It's purely a method which belongs to only tree class. Again the error pops up. Let's keep it as such. Now inside the main method you should notice that we have a plant p equals new tree of. So what happens here is we cannot create an instance for interface. Interfaces can't carry an instance, right? Only a class can carry an instance. So we are creating an instance of tree class and assigned it to the plant reference variable. This is a reference variable. P is a reference variable pointing to whose instance? It is pointing to the tree's instance. Okay, pretty good. Is that acceptable? Yes, because it's more of a polymorphic style. Plant is a base interface which can carry the instance of an implementation class. This class is implementing the plant, so this becomes a child. According to the plant, this becomes a child. So child reference goes into the parent reference variable, but technically we are not creating an instance for plant. Interfaces can't carry an instance, right? So after creating an instance, what we are trying to do here is system.out.println of we are using p dot grow. Okay, so this is how we need to do it actually. So if this is the case, we need to check what's the output of this, right? But anyways, we are not going to get the output because already we have a compile time error in the class tree. So that need to be suppressed first. So in order to suppress, I'm just using an overriding mechanisms of removing the parameter. If we remove the parameter, then the issue is resolved according to code snippet. So from the code snippet perspective, it's a compile time error. Why compile time error? Because you are implementing two interface and there are two default methods with the same signature, and you are not overriding them. Because if you're not overriding, it gets into the conflict between these two methods, which methods need to be inherited. Compiler ends up with a conflict, and so it is raising an error. But the solution is you can override it. After overriding, if you want to use the functionality of both the interface grow method, then you can typically use plant.super and living.super and invoke the method. But that's not what we are doing. We are just returning super growing. Okay, so now there is no problem. Let's observe what's the output of this p.grow. P is having whose instance? Tree's instance, noticeably, but p technically is belonging to the plant. That is the plant interface. So when I run this program, so the output is expected super growing because the instance that you have here is trees instance. Notice that it is carrying a trees instance. So even though it points to the plant P, okay, it is not picking up the plant P grow method. Okay, the plant grow method is not invoked. It is invoking only the tree grow method because it's already overridden, and you have the instance of the tree class in here, right? But in your code snippet, what they are further doing is they are converting this P into, means they are typecasting it to another type called living. Okay, so now from the compile time perspective, how it looks like is P is first converted. The P reference is going to be converted to living. Okay, and on top of the living, you're going to call this grow method. So that's how it looks like. So even though it's an explicit typecasting, what we are doing, okay, converting it to a living, what instance you have inside the P matters. Which instance we have? Tree instance we have in P. At the runtime, when the P which is carrying a tree instance is getting typecasted to a living, is it practically possible to get typecasted the tree to living? Yes, of course. Why? Because living is also a parent for the tree. Tree is in class, the parent interface is living. So living can carry tree instance, or even the plant can carry a tree instance. So plant which is carrying a tree instance currently, okay, is getting explicitly typecasted to the living, and further on top of that you are going to call the grow method. So compile time there is no problem, but we have to observe what's the output at the runtime, right? So runtime, what's the output? Is there any exception? No exception. Super growing is still printed. Even though you have typecasted to the living, okay, the reference is still whose reference? The tree's reference. That's the important point here which you have overridden. So it always talks about the instance. So even though it is a living type, the reference type is going the appearance of the reference is like living, but the reference by itself is carrying only the tree's reference. So it will go and look out for the grow method inside the tree class and pulls out the output of that particular grow method, right? So there is no class cast exception that's happening here, but you will get a class cast exception like this. If I'm not implementing the living, okay, only plant is implemented, and plant can carry the tree reference technically because class instance is what goes inside the interface reference variable. And here from the reference variable, while you're doing a typecasting to a class which does not relate to the tree at all, okay, interface living is not related to tree at all. At this point of time, if you try to run the application, you will end up with a class cast exception. Why? Because you are trying to cast the type into another class type which technically doesn't belong to this tree tree is not implementing the living, so it ends up with a class cast exception. But this is not the actual output of the code snippet. Code snippet is already having an issue in the compile time error itself, right? So the actual output is compile time error according to the code snippet. So if I go for living, and your casting will work. So we need to understand this class cast, the class type casting more importantly. So we are only getting the super growing as in this case, right? So if in case, let's say if I have different methods here, okay, then the conflict will not occur. The method names are different, then the conflict will not occur. If the method names are same, the default method names are same, and the signatures are also same, then technically you will be facing a challenge. Okay, so in that case, the solution is to override the grow method inside the tree, and there the problem is resolved. So according to the code snippet, the actual outcome is we are having a parameter here which is int height that says that this method is not an overridden method. It's not an overridden method, and since it's not an overridden method style, the tree is facing a challenge that there is a duplicate default methods are available. So if you just have plant implemented, then the problem is solved because it looks more similar like a single inheritance. If it's a single implementation, then obviously you're not going to end up with any problem. But the problem comes when you're going for multiple implementation, and if both the interface carries the same signature of the default methods is where the problem is. This is applicable only for the default methods. So let's say, for example, I have an abstract method, right? So I have an int add int a comma int b. Okay, so we have an add method which is an abstract method. I didn't give any definition for this method, right? And coming down to this interface again, I'm going to have the same signature, which is going to have int add of int a comma int b. So signatures are all same, but they both are abstract methods. So if you notice, they both are abstract methods, and here in this case, let's say I have grow 1 time being. Okay, it's the method name is different. So right now the error is different. The type tree must implement the inherited abstract method. Mandate you need to override the method. But which method will you override? Plant method or living method? It will be an overriding mechanisms which is applicable for both the interfaces. So there is no problem at all when it is an abstract method inside an interfaces, right? So we will tend to override them as int add int a comma int b, and you override this. So in this case, technically there is no challenge at all. So why we don't have any challenge as in this case is because we are trying to override the method, and post overriding, what happens here is this is a explicit definition that is given only inside the class. These are abstract methods, right? So both the interface, even the methods are same in terms of an abstract nature. You are overriding for both the method as a single overriding logic. Okay, it's a single overriding logic, so there is no problem that occurs. But that's not the case for default methods. Default methods, if they are having the same method signature, you will end up with a trouble, and there where the solution comes in with the overriding that default method. And if in case you want to make use of the functionality of the interfaces here, then you need to use the super keyword prefixed with the interface names. And what happens here is a typecasting. So since there is a relationship between plant and the living with the tree references will be technically extracted even if you do an explicit typecasting to the living, because tree is related to living. But the outcome what you will get is only the overridden value of outcome. This is an overridden, it should be an overridden method if in case you don't have the parameter here. But as per the code snippet, you have the parameter that leads to the compile time error. So what is the actual compile time error according to the code snippet is duplicate default method named grow with the parameters are also same, are inherited from both living and plant. That's where the challenge is, right? So what are the concepts that we have learned here is the new features of Java 8 interfaces, that is default methods. We will come across with static methods probably in another code snippet, but right now you notice that you can have a default method inside an interface going forward from Java 8, and also you can carry an abstract method, and also you can have a static method. But according to the code snippet, we don't have any static method, so we are restraining from understanding the concept of static method. And moreover, the typecastings are very important. Please understand the typecasting, because there is a relationship exists between the tree and the plant and the living, and so it's pretty easier for you to keep casting between them, okay, and you'll be able to access the overridden methods output. But right now we end up with a compile time error because we face a duplicate default method. This is the exact code that we have on the code snippet. So according to the code snippet, now you will understand that why the outcome is a compile time error. So this is a pretty lengthier video, I knew, because we have a lot of intrinsic concepts to be understood in order to crack this code snippet. So we'll catch up with another interesting code snippet, and in next video we'll have more deeper understanding if we get a chance to get into the static methods as well. So thank